look for you to, there we go. All right, good evening. Appreciate you all for joining. My name is Preston Miller, and I will be your instructor for the next few weeks as we talk about AI security foundations. Essentially, what we're going to be doing is taking a high level look at some of the implications as it relates to AI security and this new frontier that we find ourselves on. We're going to start off with talking about some of the differences from traditional security, dive into some of the security frameworks, and also talk a little bit about some of the novel attack surface that AI introduces into computer networking. Start off with a quick meet your instructor. Again, my name is Preston Miller. I am a cybersecurity engineer. I've been in cybersecurity for about 20 years, dating back to my time in the military. I spent about 10 years in the Army where I did some IT work. From there, I found myself working for the federal government for a few years, mainly incident response and cybersecurity engineering. And now in my current role, where I'm more focused on cloud risk management, governance, and vulnerability management. A quick agenda over the next few weeks. Again, this is week one. We're going to be talking about the new attack surface for AI security. Over the next few weeks, we'll dive a lot more into some of the implications and ramifications of AI in cybersecurity, looking at different things like data integrity and poisoning risk, how attackers tend to attack the data models that AI uses. Week four, we'll do a deep dive on the AI, the newly formed AI governance frameworks and compliance frameworks. Week five, we'll take a look at how defenders are securing AI systems. And then the last week, we look at some of the future trends and the human element of AI security and systems. Here's what you can expect over the next few weeks. So this is going to be a 6-week course. And we're going to actually be looking at 1 hour sessions. I know it says 2 hour sessions here, but we're going to be doing looking at 1 hour sessions that are worth CPEs and CEUs. You can expect to explain and know how AI systems differ from traditional security and hardware and why this matters for security. You're going to be able to at least identify a few of the major threat categories that AI systems holds, including data poisoning, model inversion, and prompt injection. We're gonna understand the emerging AI governance frameworks, mainly from ISO and NIST. We're going to be able to at least to be exposed to the concepts of practical defensive strategies and governance principles for securing AI systems. And then lastly, we're going to be recognizing the importance of the human element in oversight of the ethical responsibility in AI security. So again, welcome to week one, where we going to take a maybe just a cursory 50,000-foot view of AI and the way it changes security. Learning objective for this week. We're going to learn, we've been talking about the fundamentals of AI security. And we're really going to focus on highlighting the difference between what we recognize as traditional cybersecurity, right? So your ones and zeros, your securing the hardware, your application security, and really juxtaposing that with the what we identify as AI security, right? It kind of turns that narrative on its head, or some of the concepts on its head, and we're going to talk about the little bit of the differences. We're hoping that some of the key learning points for you are going to be understanding the different components of AI security, understanding that new attack surface, and the potential threats therein. This is expected to be an interactive course. I do have some questions in there that I have sort of framed as a poll, but I think this may be better in just a more of a dialogue, right? So we're going to take some strategic pauses throughout the lesson tonight, ask you some thoughtful questions. I would love to hear from some of you all and get your thoughts and comments on some of the and your feedback on some of the questions that I've posed. All right, so diving right into it. the first thing we want to do is again just kind of set the stage for what we mean by AI security, right? So you can think of security writ large from a security perspective when it comes to IT systems as doing one of three things or all three things simultaneously, right? So protecting the confidentiality of the systems and data, protecting the integrity of the data, and protecting the availability of the data and systems, right? So confidentiality, wherein, hey, can if I send a email over to my colleague, can it be intercepted? Can an attacker get that message? If I'm sending business reports, if I'm sending secret keys over to someone, our colleagues in China, can it be intercepted by malicious and nefarious actors and used for nefarious purpose, or or a ransomware situation from an integrity standpoint? Hey, can somebody maybe not steal the data, but can they come in and change the data in a way that from the original data set that causes issues and causes a lack of trust in our computing systems, right? So, for example, we see this a lot in IoT systems or systems that control things like power grids, where an attacker will maybe hack into a system and not steal anything, but maybe change a sensor or change a production system that completely disrupts and throws off the systems because the integrity of the information wasn't there. And then lastly, availability, right? Is that system, is that data available to us when we need it, and for the purposes that we need it, right? So if I'm running a large e-commerce website and an attacker decides that they're going to flood my website with a fraudulent request there and bring that website down or bring it to a halt or a very slow response time, then that means users who are actually want to do business with me cannot interact with my system, cannot get to my products, and therefore the availability isn't there, right? So from a traditional standpoint, that's really what we focus on when it comes to cybersecurity from a traditional IT systems and computer systems. AI takes a completely different approach there, right? Because traditional programming relies on explicit and defined rules. Hey, when a user makes this request, here are the defined things that can and will happen. AI takes a different approach, is that in that it is learning on the go, right? So there's not going to be a defined and expected and the same output when a user makes a request to an AI system, right? So when I type into my computer on a calculator, I press 101. 101 is going to pop up on the screen. When I interact with AI, I am feeding it information, and the AI is putting together a answer based on the data models. So that again, from a security perspective, that's a completely different outlook. We have to prepare our defensive and prepare our security for what the model may produce as a result of what the user feeds it to as a prompt. Also, the learning patterns are unique and different when talking about AI systems, right? The AI system derives its insight from data identified as pattern and relationships, and that will change over time, right? The more data an AI system collects, the more it's going to be able to prove its responsiveness and flexibility, which also means the type of components and systems you need to put in place to stay ahead of anyone trying to attack that model also needs to be able to adapt and also needs guardrails on how that AI system will respond as it's learning, as it's adapting. When it comes down to what matters most from a security perspective with AI systems, we already talked about what matters most from a traditional computer system, right? Our confidentiality, our integrity, our availability. For AI systems, it's a bit different in that what really matters is the data quality, right? We're not as concerned with whether the data we've received from AI system is confidential, whether, of course, availability matters, but when securing an AI system, those things kind of happen on the back end. When we talk about what we get from AI system, it's really about the data quality. Can I trust the information that the AI system is giving me? Can I trust that someone has not poisoned my model in a way where I'm going to now get it hallucinating results, fraudulent results, maybe exposing data that should not be exposed when I ask it a question. So those become the things we care about from a securing AI perspective, right? So again, confidentiality is there, availability is there. It's for the things we care about, but really what we care about, what's paramount to us, is the data quality. Can we trust what the model is telling us? Can we trust that whatever's happening on the back end when I ask that model a question, can I trust that it's using the trusted sources to model that answer for me, as opposed to if someone, an attacker, coming in and poisoning the model for it to give out bad or fraudulent information. A little bit more in the traditional layers of versus AI. Again, so traditional security system is relies on fixed rules and defined processes, and there's sort of defined layers of traditional AI, where that from your application layer down to your hardware level, right? Each of those layers has its own sort of approaches to cybersecurity, own approaches to control sets. The nature of threats are limited at each of those levels, right? The same type of attacks that would work on your application level wouldn't necessarily work on your hardware level. And where AI layers is a new stack by data driven layers. So data is where the model behavior becomes the component of security, right? And data flows throughout the entire AI system, right? From the back end where the model is being produced to the front end where the users interacting with the something like Chat GPT, a LLM, or a agent or a copilot. So data is the commonality between all those layers, which means we're looking at the entire system and how we secure that entire system, as opposed to maybe these different layers. In this paradigm, data becomes the new code. Think about the backend systems where your traditional thoughts about engineers in the back room running their Python scripts or coding in Python to develop a new application. In this world of AI, data is that new code, right? So it's paramount to protect that data throughout the life cycle to protect the AI system. Talk a little bit about how AI learns. The first thing any AI system does, whether that's a large language model, whether that's an agent, it collects raw data from various sources, right? So, and the creators or the developers of this AI system will ostensibly test for these data sources to be trusted. But that's really where it gets its foundations from, right? For example, someone you may create an LLM, say, hey, I want you to scour every single social media network for the most effective influencers or the accounts that have the highest following, and look for common threads and how they interact with their audiences, and that is your model. We're going to train you in that model, and your sole purpose as an AI system is to be able to teach people or interact with people to make them superstar influencers on any social media platform they choose, right? So these then you would take the raw data, right? Whether that's video clips, whether that's text files, whether that's backend systems, right? Logs from backend systems, and you would train that AI model to look across all their, make decisions. Look for patterns, and to be able to put together a cohesive, legible, very human-like response when the models ask questions about the data that it knows about. So that's really where AI starts and how it learns. There's a number of pre-processing steps that happens before it spits out, a legible, readable response to a human. It undergoes a series of cleaning and transformations to ensure that the quality inputs are there, and these are meant to enhance the model accuracy and reliability during the training process, right? So a AI system is constantly being trained on either old data or new data to make better, more refined, more effective outputs, responses to humans, right? And the more you interact with the AI system, the more it learns, right? So the model is really good at taking language that's being used, that's being fed to it, and sort of using that as the next training step, right? So, for example, you prompt a AI system, it doesn't quite give you the response you're looking for, and you say, actually, that's not a goal we're looking for. I'm looking for something more like this. It can take that, store that in memory, and use that as a new sort of training thread for how to interact with you specifically, and that becomes part of his training model. And that's the feedback loop, the segue right into the feedback loop. The model is going to continuously learn from user interactions and new data, right? The more people interact with that training model, the more it's able to extract patterns for how people interact with it, and the better responses it can give you. Hey, I noticed that. A large amount of people or a majority of people like when I respond this way when he asks this type of question. It will learn from that and keep improving on that model. This, of course, the idea that that data is the new code and data is the new lifeblood of the system. This, of course, it creates a new attack surface that has some similarities, but has some true differences from traditional security, computer security. So, we want to introduce you conceptually to a couple of the emerging AI security threats that we've seen the larger cybersecurity community is becoming privy to, have seen, and also have continued to take steps to be able to identify and head off before they become serious issues. One is data poisoning. I mentioned this a little bit up top, right? So that's an attack where a attacker will manipulate the training data to mislead AI systems, resulting in incorrect outputs or undermining the system reliability. Um, Again, an example would be that model we talked about earlier, right? Hey, give me all the information, or I'm gonna train you on all the social media data for influencing, and I want you to be able to make smart, reliable responses to folks when they ask for, hey, what do you think what do you think is the top ways to engage with the audience if I'm trying to be a fitness guru or a fitness influencer, right? So someone can come, hack into the back end of the AI system, poison that data by reducing the number of fitness training accounts it has access to, or, for example, relabeling makeup tutorials as some sort of falling that under a fitness category. And again, that data now that's not trained on that, it's been poisoned, and you're going to get some unexpected results when folks try to ask that question, some salient questions of the AI system. Model inversion allows adversaries to extract sensitive information from AI models, essentially reversing the learning process. And this poses significant risks, but it also it necessitates robust defensive and ethical guidelines for AI deployment, right? So model inversion is basically um, asking your way of an AI system to reveal some data that you probably shouldn't know about, right? In the example that I keep using, right? Hey, uh, how many fitness influencers have you been trained on? It may give you a number. You drill down. Hey, can you tell me the geographical region of the right of these influencers that you've been trained on, right? And again, being able to kind of drill down into prompting, asking the questions of the AI. And you get to a point where now you're able to get things like maybe name, address, phone number of some of the influencers whose accounts they've been trained on, because there aren't the right security controls in place to prevent the AI from responding, right? Typically there are safeguards in place, but AI does have a tendency to be super responsive to users' needs, and asking it the right way at the right time may yield some unexpected results. So again, it's really drilling down through question and answers and a little bit of trickery, language trickery with some of these models in order to extract some sensitive information out of the AI system. And last but not least is data quality, right? So prompt injections get the prompt the AI system to respond to malicious inputs, right? So leading to unintended behavior. For example, right, someone you could be asking a series of questions, and you could in that to an AI system, in that you maybe inject a string of characters that acts as a trigger response to the AI system. And it could, lead to a lot of unintended behaviors, whether that's getting the model to respond in some sort of funky language, whether that's getting the model to hallucinate even more, whether that's getting the model to sort of poison its own data sources. So that data quality through prompt injection is probably the more prevalent one that we see nowadays. But all the others are equally as concerning when it comes to being able to operate and trust any AI system. So I do have a little bit of a case study for you to put that AI hallucination case sort of in context for you. Um, Give me a second here. So I'm going to tell you a little bit of the story about what a real life story about AI hallucination and some of the really tangible impact it can have on a company. So there was a security service provider who deployed an AI threat intelligence assistant to speed up alert triage, right? So they installed this AI threat intelligence assistant as an agent. Right, so whenever alerts came into their security, to their security apparatus, to their SIM, they would let the AI threat intelligent agent sort of direct them in speed and to speed up the process and triage. Like, hey, this is actually a level 1 threat. You probably need to pay attention to this immediately. We saw the patterns across the threat intelligence that we're privy to, and this is a significant threat, right? So they were using that for speed, taking some of the load off some of their analysts. Um, Doing a ransomware investigation, an analyst asked the AI to identify the likely threat actor, right? So there was a ransomware that occurred in this organization, and they used the AI threat intelligence assistant to say, hey, based on what we see in this environment, based on the TTPs, the techniques, tactics, and protocols, can you give us a sense of who may be responsible from a threat actor perspective? The AI confidently attributed the activity to a ransomware group, a well-known ransomware group, although none of the indicators matched. The incorrect attribution was shared in an executive briefing and with the client itself, and it essentially ruined the credibility of that security service provider, right? So the model relied on semantic similarity, right? It saw similar names, similar context, similar file structures as the known threat actor, and it made an assumption, in this case, an hallucination, to say, "Oh, we're without doubt confident that it's this ransomware group," and the training also included some outdated internal reports, causing some false associations, right? So and also, what was at play here is the prompt was too broad, right? So the analyst asked to the AI to identify the likely threat actor, and that caused it to sort of have this broad, sweeping analysis to go out there, and it sort of made that assertion that in fact, it was a ransomware group that was well known when it was a ransomware group that hadn't been heard of before. And again, that information got floated up to the executive level and also got floated up to the client that they were servicing, and it completely damaged their reputation and really eroded the trust between them, and their customer. I even have a personal story about AI hallucination. I am a Chat GPT fan, correspond with it quite regularly on different things. And I was chatting with it the other day, and it responded to me, and it said, "Hey Jay, that's a great idea." I'm like, "Wait, who in the world is Jay? Because that's not definitely not me." And then it gave me a story of, oh, sorry about that. I had too many things in my queue, and I made an association with a name you had used months ago, thinking it was your name. So I just found that fascinating that it had the sort of the wherewithal to make that kind of mistake, and also had the wherewithal to sort of explain itself. So hallucinations are not a real thing. They're actually a pretty common thing with AI models. So that really highlights the need for that human interaction and human oversight of the AI models, right? And just do not take what these LLMs and these agents are giving you blindly. There certainly needs to be context, nuance added, and a double check from a human perspective. Let's talk about some of the traditional security shortcomings as it relates to AI systems, right? Why the thinking of the past in these traditional security models won't work against some of these modern threats that we see, right? Um, Firewalls alone, right? So one of the main staples of traditional security of networks and computers is firewalls, right? Computers talk over a computer network. Those computer networks travel over the broad internet infrastructure to communicate, and the broad internet infrastructure uses network protocols to make certain connections. Right, those network protocols can be managed, denied, blocked, allowed via firewalls. Right, set a firewall in my boundary. I could configure it in a ways to only safe and trusted networks can talk to my network. Safe and trusted computers can talk to my computers. Right. That no longer works when we talk about AI systems, because it's not the connection to the network that matters, it's the data quality that matters, right? And firewalls do not and cannot ensure data integrity. Even even our most advanced firewalls that do deep packet inspection, they're not checking. They don't have privy to. They can't see, and they're certainly not capable of checking data quality. And that goes across the board for any of our traditional IT security sort of products and concepts, whether that be endpoint protection, whether that be intrusion detection systems. None of those devices, none of those concepts, none of those controls are are going to be successful or adequate when it comes to AI models, because none of those are equipped to handle and ensure data integrity, right? So these static defenses will fail. Um, and because of the nature of these defensive, that they will not be able to catch up to something like a ever evolving AI system that is going to continue to evolve in a model, and attackers going to continue to find better ways to attack that model and manipulate that model. So we have to shift our focus from our traditional security of firewalls, policies, endpoint detection, to more of a continuous validation of data quality to ensure security of AI systems. Yeah. Um, so there can also be all AI systems can really. I think the real nuance here is AI systems can take something small, right? Misinterpret a small change, and interpret it as something like something else, which completely changes the context of the expected output, right? The example that I use here, right? You train an AI model on a number of photos that have to do with street signages, right? Speed signs, speed limit signs, stop signs, parking signs, highway signs, whatever, right? And let's say that that AI model perceives a stop sign as a speed limit sign, right? Not a big deal, right? Maybe in that one instance, but if we're asking that model to give us a sense or train our bus systems or some sort of autonomous system, like Waymo or Robo Taxi, on the best routes to get from A to Z, and it's confusing stop signs with speed limit signs, you're probably going to have a real legitimate problem on your hands, right? Again, I think this highlights the significant impact of what maybe seem minor in the moment, and how it can have very, very serious and safety critical implications. So I'm going to pause here. I know I've kind of thrown a lot at you, but I just want to take a moment to let some of that soak in, and just open up the floor for just a quick discussion and maybe some feedback and some thoughts about some of the things we went over so far. So I just want to pose a question to kind of get the conversation started, right? So when AI systems can both defend and attack, who do you think holds the responsibility for managing the security risk they create? Next question here is, think about a tool like Chat GPT, Copilot, or Gemini. What kind of vulnerabilities could these introduce into an enterprise environment if they're not properly secured? Um, really, really interested in anyone's feedback or comments on that second question. A lot of organizations are adopting more and more sort of AI agents, enterprise solutions for things like Chat GPT, Notebook LM. Just want you to think about, from what we discussed, what sort of vulnerabilities and what sort of issues could those introduce into an enterprise environment if they're not properly secure? Anybody?
Um,
Yep.
I know for the second one, um, they can the vulnerabilities I would think would be like the users, one of the users if they give out certain information. If they're in an
Hmm.
enterprise, like that could be dangerous. I know for my company, we had some AI training where giving out certain personal information
Sure.
is dangerous. And to just kind of minimize that, fact check the information that the AI bot is giving you because it could be misinformation. Um, and I would say who is responsible for managing the security risk would be, I guess, whoever made the AI.
Hmm. Yeah. Yeah, yeah, great feedback, right? So I'm gonna take a moment to talk about both of those, right? I started the second one, right? I think you hit the nail on the head, right? That's just one of the many problems. Something like Chat GPT and Copilot and Gemini introduced into an environment, right? Because on one hand, to get the maximum use and effectiveness out of one of these tools, you're gonna have to give it a lot of data about your company, right? You're gonna have to give it data about your business, maybe even your customers, your employees, maybe even sensitive data, sensitive business process data, right? Because if you don't train it on that, then what's the use of having it, right? You want to be able to go to one of these tools and say, hey, can you give me a rundown of our last 3 quarters, right, from a profit perspective, right? And it's you expect it to give you a sound answer or a right answer, but it also means it's going to have access to a whole bunch of informations and a whole bunch of transactions between you and your clients, right? Those transactions may include very sensitive information like um, payment information, right? A client's routing information, right? Because that of course will inform your profits and maybe go into that report. But what if there's a nefarious actor out there who can exploit that and say, hey, I want to know exactly which clients paid us this quarter, and how much they paid us. And oh, by the way, I'm doing more research. Can you give us routing numbers from the banks and routing numbers from where they paid from, right? And that becomes a serious issue from a privacy standpoint. Yeah. The first question here, right? Who ultimately holds that responsibility? That I pose that as sort of a thought exercise because as of right now, there is no right answer to that, right? Um, if I'm developing, or what we often hear is, as an AI the system developer, it isn't my job to secure it. My job is to make sure it works. My job is to make sure that it's trained on the right information. My job is to make sure it gives the right output to the clients, right? Is it available for my customers to use? Is it workable? Does it give reliable information? Yeah, that I may be upset if it returns a hallucination or returns some sensitive information, but that's certainly not my primary role or the primary reason I'm creating this model. I'm creating this model for folks to interact with it. I'd rather push that responsibility off on someone else. Right. So that becomes sort of the chicken and the egg argument, right? Or the cart and the horse argument of, should the AI system developers be responsible for the models, or should folks whose job it is, who are trained for and know what to look for in AI security models, is it their job, right? So again, not a real clear answer there. Certainly a worthy thought exercise, but I think there is some shared responsibility on both sides there. So we're gonna take a little bit more of a deep dive into understanding prompt injections. I talked about this earlier, but prompt injections essentially represent a critical vulnerability where a user can craft a specific input in, whether that be gibberish or whether that be in a plain language, where words or a question asked just in the right way to get an unexpected response or unintended response from the AI model, and this leads to breaches of confidentiality and integrity, because it's going to generate outputs in various ways that the developers of the AI systems didn't intend to, right? Um, yeah, the example here is, um, right, you feed the AI some gibberish, with a little bit of knowledge of, or maybe through trial and error, and you can see the AI responding in gibberish. That means that prompt injection has worked, right? It is because the model was not trained to respond in gibberish. However, you got it to respond in gibberish through a series of prompts, that had an unexpected or unintended output for the AI system. Talk a little bit about the governance frameworks. We're going to do a deep dive on this later in our courses. I think this is around week 4, week 5. But these are the newly formed governance frameworks for AI. And they're all about ensuring trustworthy AI systems, right? So what should organizations be doing organizationally, from a policy perspective, from a system perspective, to ensure trustworthy AI systems, not confidential systems, not available systems, right? Not systems with integrity, but trustworthy systems, right? The lead in this is the ISO IEC 42001. The standard provides a systematic approach to establishing and maintaining management of AI systems. ensuring the consistent quality and compliance throughout the life cycle of AI systems. The NIST, the newly formed AI RMF, NIST being the National Institutes of Standard Technologies, probably the most known one in certainly government sectors and in the IT space in the United States. It offers an AI risk management framework focused on integrating the traditional risk management principles into AI development, with the focus on reliability and reducing those risks associated with AI technologies. In the EU, the European Union AI Act, this regulation aims to create a legal framework for AI in Europe, where it's promoting accountability and ethical use, right? So back to that first question, who's ultimately responsible for securing the AI system? The EU AI Act intends to promote that accountability action, right? So, hey, developer, hey, AI system creator, we're going to ultimately hold you responsible from a legal perspective for the ethical use of your AI systems that you develop. Um, and it tries to establish some fundamental rights and societal values around the use of AI, right? For example, taking someone's picture on the internet, creating a deep fake video of them doing something that they haven't done before, right? Is that an appropriate use of AI? Is that an ethical use of AI? And if a platform like Sora is allowing that, should they be held legally liable or accountable for the things that are generated and shared on their platform and using their tool and technology. So those are some of the things that the EU AI Act tries to address. Yeah, and again, all this is in the early stages. There's some really great work being done around establishing these frameworks, but it's going to be a learning process as we go. But yeah, these frameworks are trying to get in front of some of these larger societal ethical issues that AI systems pose. This brings us to our key takeaways and our look ahead. The main takeaway here is that AI systems present a new attack surface, right? And it sort of extends that cybersecurity landscape, introducing unique and novel vulnerabilities, where we're really focused on data and the model layers that traditional software and hardware just simply does not address. So it's going to commend us as security professionals to develop and continue to foster a comprehensive understanding of these new risks, right? And how to protect um, society and our users from these risks. There's a shift in perspective where we see data as a new code, right? And the data in this instance is the data that the models are being trained on, that essentially becomes the code that our traditional applications are built on, right? So how your traditional applications are built on something like Python, AI systems are built on these data sources that they're trained on. And again, that emphasizes the critical need for data integrity and quality in AI system to prevent those exploitations and failures. And last but not least is the importance of human oversight, right? I mentioned this earlier, but human oversight at this stage is absolutely critical and paramount for trustworthy AI. Right. So that means ensuring that governance frameworks are in place to monitor and validate AI systems and their output. There's a human in the loop. All right, we're not just blindly trusting what AI systems tell us, what they produce, what they model, what they analyze. There certainly needs to be a human in the loop to promote that accountability in decision making. That wraps up our class for this week. Next, we're going to be looking at exploring data integrity, right? So again, the theme throughout the talk tonight has been about the quality and integrity of the data. We're going to explore that a little bit more and talk about the security risks associated with that next week. And with that, I do thank you for your time. I am going to pause for any questions, any comments you may have. For any questions related to this course, if you don't have any tonight, you can email me directly at the email on the screen here. You can also book me for one-on-one sessions. directly through the Kyora AI app for personalized supports and guidance. Not only on things like AI security, but also if you have questions about how to get your career started in cybersecurity, different aspects of cybersecurity, or even just to ask me about sort of my journey in cybersecurity and any guidance that I can give you there. I'm certainly open to that, and you can book me for a one-on-one session on that end. And with that, I'm going to quickly pause to see if there's any maybe questions that you may have. And yeah, and can take it from there. So I'll just pause really quick to see if there's any questions.
I have one quick one.
Yep.
Will this class, will it have any hands-on AI related security stuff like security related protocols for AI tools, or is it just going over the premise of AI within security?
Yeah. This is primarily exploring sort of the concepts of AI security.
Hmm.
There won't be any labs associated with it, right? We won't be, setting up our own LLM and practicing sort of prompt injections or anything. Yeah, so that is not a part of this course. I imagine there are other courses in the works that will and labs in the works that would explore that, but this class we're really just taking a conceptual look across the board.
Okay,
Yeah,
thank you.
yeah, I appreciate that question.
Mhm.
Yeah. All
I have,
right. Yep.
I was going to say, at the end of the 6 weeks, is this something that we can put on our resume, like that we, I guess, know AI security foundations and we can explain it in the interview?
Oh, absolutely. Yeah, absolutely. Yeah. Well, I will say that at least to my understanding, I don't think there is a certificate that comes with the completion of the 6 weeks.
Mhm.
But this is certainly something you can say, hey, I took a 6 weeks course. I understand conceptually the premise of AI security and how it differs from traditional security. And I would certainly feel confident putting it on my resume. Granted that you can actually speak to any question they may ask you,
Mhm.
which that is the hope of this class. So, but yeah, absolutely.
Perfect. Thank you so much.
Yeah, you're very welcome. Very welcome. Yeah. All right. If no other questions, I really appreciate your time tonight. Thank you for joining, and I hope to see you all and hear from you all next week.
Thank you. Bye.
Bye.
Thank you. Bye bye.